Welcome to this video, and we're going to be looking at total differential. So total differential is just a way to approximate the total change in a function that depends on multiple variables when all these variables have or change by a small amount. So now when we're dealing with a single variable, let's say a function of y equal to f of x, then the the change, so this what the total differential tells us is just the approximate change in y for a small change in x, and that is denoted as dy then f prime of x dx. So this tells us the approximate change in y for a small change in x. So now for total differentials of a function of two variables, let's say z equal to fx comma y, for such you have that it's going to be defined as dz going to be equal to, so you have partial of z, so partial of z with respect to x, then dx, that's the change in x, then partial of z with partial of y, then dy, that's the change in x. So so this partial of z, partial of x, this partial derivative with respect to x, it just measures how that f or that function changes, uh, changes as x changes. So as x changes, and of course as we hold y constant, then also the other one, partial of z, partial of of y, this is this is partial derivative of f with respect to y. So this here is just showing us, as we had said before, the change as y now, and holding the x, the x constant. So the dx and the dy here, the dx and the dy are just small changes, changes in the independent variables of x and y. Of course you could extend this to further on, uh, other, maybe to a function of three variables, going on just like that. But well, let's apply. How do we apply this here? So what is important to note is this here, what we have written here. This here is what is going to help us to find, or to apply this total partial, which is just the a change that we're trying to find, change in in that function, so a change in z. Okay, so we get that there. So what do we need then? So we need to then find this partial of partial of z with respect to to x, partial of z with respect to to y, is what we have to find. So I first find my partial of z with respect to x, and that there is just going to be, so for the first one here, meaning I am differentiating my x, keeping the y as as a constant, or treating it as a constant. So I just, there first part, I'll just get 2, I get y squared, then there you get plus 2xy, then you have plus y cubed, like that. Then the next, say we find the partial of z with respect to y now, and that is just going to be 2xy, then you have there x squared plus the 3xy squared. So this is what you get. Now we write we write this as a partial derivatives into into this formula here, or into that form there, which is just going to be dz, dz here, is going to be the partial of z with respect to x. We found that to be y squared plus 2x y plus y cubed, then dx there, plus the other one, that's just 2xy plus x squared plus 3xy squared, then I write my dy like that. So this is how you do it for the first one. We do the same for the second one. Really, writing or finding the total partial derivative of a function is really easy. So we do it like the next one. So z, meaning I get partial of z, partial with respect to x. First of all, for the first one, what am I going to get? So I have this x cos y, x cos y. So what do I do with that one? So to find this x cos y, here I differentiate with x, meaning I just remain with the cos y, cos y, the first part. Then here I differentiate with respect to what, to x. So differentiating the sine x, I'm going to get cos s. So this is going to be y, then cos what, cos x, like that. Then I do partial of z, partial of y, and this is going to be, so I look at that partial of y, what is it going to be? So I have x, the partial of y here, differentiate the cos y with respect to y. That of course just gives me negative sine, so that would be negative sine what? Sine y. Then I have minus the y differentiated, so the y there goes in front, I just remain with sine what? Sine x. So this here in written as negative x sine y minus the sine x. So I found the two. So next I just use the formula is there, dz, meaning is going to be equal to, so I have cos y minus the y cos what, cos x on the first part there. Then I say this dx plus the one that follows, that's negative x sine y minus sine x. Then I say dy. Of course here look, I can factor out that negative. Then I have this will be cos y, then minus y cos x, like that. Then I get this dx, then I factor out the negative, goes there. Then I get x sine y minus sine x, like that. Then I say dy, and that's how I find the total differential. Well, remember to hit the subscribe button, and I'm gonna see you in the next one.